So next topic, pericyclic reactions. So before going into the reactions, what are there are three types of reactions. We have electrocyclic, cyclation. Before going to them, first you need to know how to identify the ground state, and then what is HOMO and what is LUMO, then about Carn rotation, disrotation, how these things differs in case of photochemical condition and thermal conditions. So those things we talk today. So first we'll take a simple molecule, that is ethylene molecule. Okay, so the number of molecular orbitals is equals to number of pi electrons. Okay, here we have number of pi electrons are 2, right? So total number of molecular orbitals also 2. So those two molecular orbitals are psi1 and psi2. Okay, so we have 2 pi electrons. Those 2 pi electron will fill here in case of thermal condition, whereas in case of photochemical condition, so one electron from here excited to the from psi1 to psi2. So this exists like this. This is in the photochemical condition, this is in the thermal condition. So now under photochemical condition, the HOMO is psi1, HOMO is psi1. Under photochemical condition, the HOMO is psi2, and here the LUMO is psi2, and here also we can say LUMO is psi2 only, because further there is no electron, there is no orbital, so we can say psi2 HOMO as well as LUMO in this case. Okay, now there are two symmetry criteria to identify whether it is psi1 or psi2. So two orbitals we take like this. Just remember this psi n. See, if n value equals to even, one condition, and n equals to odd. So for psi1, n value is odd. So when it's odd, in that case there is a presence of plane of symmetry. When it's even, there is a presence of C2X of symmetry. Okay, so this will be shaded, and this one. So this is for psi1 because there is a presence of plane of symmetry. And when we are talking about C2, so this will be the for C2 because here we have a C2X of symmetry. Okay, so when n value equals to odd, in that case plane of symmetry has to be there. When n value equals to even, that in that case C2X of symmetry has to be there. Now, so here only we'll talk about the HOMO is done, LUMO is done. Now we'll go for the Carn and disrotation. Okay, so we'll take psi1. Sorry. So psi1 means there is a presence of plane of symmetry. Okay, what is the Carn rotation? Carn rotation means both should be towards same direction. Okay, now so now we are rotating this one this way. So imagine like this, you can say like this. So this is the shaded shaded one. We can say this is filled orbital. So this is the filled one, this is the empty orbital, or we can say this is a shaded orbital, this is unshaded orbital. So when we are rotating this way, now after rotating, so this is coming towards your left direction, left, and this also when you are rotating this way and it's coming towards left. Okay, and when in this case what's happening uh, here, this orbital is different and this orbital is different. Okay, so because of that, in this case, in for psi1 the con rotation is not allowed, because so it has to be same, though means like two orbitals are having same like shaded or unshaded, then that is allowed. So imagine that we are doing here this rotation. So this rotation means we are moving, we are rotating this mm, molecular orbital in opposite direction. So we are rotating this one towards our right direction, and this is towards left direction. So this will be same, this will be same, here shaded region comes, and when we are rotating this way, and sorry, when we are rotating this way, yeah, so this orbital, so like this we are rotating in this way, so the shaded one comes here, unshaded one comes towards left hand side. So this is the uh, after this rotation. So see here, so both are coming, both orbitals, this unshaded are coming same side, so that means this is allowed. So for psi 1 this is allowed. If you take psi 2, for this con will be allowed. If for psi 1 this is allowing, means for psi 2 it should be con. So it's going this way and this is going this way, so this orbital comes like this, so you are shaded, and this is going this way, that means this is like this. So here con is allowed. Okay, this is about the con and this rotation. We'll talk about it in details like later in case of photochemical condition and thermal conditions. Okay, for okay, now we'll go for the important thing, that is a cyclo Butadiene system. So the Butadiene system is, this is the Butadiene system. So total number of how many pi electrons are there? 4 pi electrons are there. Because of that we'll get a 4 molecular orbitals, that is psi 1, psi 2, psi 3 and psi 4. Okay, so this condition you have to remember. When n equals to even, in that case C2 symmetry is allowed. When n equals to odd, in that case plane of symmetry is allowed. Okay, so here it's odd, it should be having a plane of symmetry, and the nodal plane also we have to remember. So nodal plane will be always n minus 1. Okay, I'll explain what is the how to identify nodal plane also. Now we'll keep orbitals here, lobes we will keep. So the like see, when we have this kind of arrangement, so here it's coming this way. So it's, if filled nodes are same side, in that case there is no nodal plane. If they are opposite side like this, so here this is above and this is below, so this will be one nodal plane, and this is above and this is below, and this will be another nodal plane. So here total we have 2 nodal planes. Okay, for psi 1 the nodal plane has to be 0, because for n minus 1 equals to 0, so that means 1 minus 1 equals to 0. That means we have to keep all on the same direction. Okay, see, there is a plane of symmetry, and now nodal planes are 0. And then we'll go for psi 2. In case of psi 2 there should be a C2 symmetry, and 2 minus 1 1, so there should be one nodal plane has to be present for psi 2. So now take 2 above and 2 below. So we have a C2 axis symmetry here, and here there is no nodal plane, and this is one nodal plane, and here also no nodal plane. Okay, this is for psi 2. And for psi 3, it should be like this: fill, unfill, unfill, then fill here. Okay, and this is one nodal plane. Here no nodal plane is second nodal plane, because 3 minus 1 equals to 2. This is for psi 2, psi 3, and here we can see there is a plane. And for psi 4 we have to get a 3 nodal planes: up, down, up, down. One nodal plane, second nodal plane, third nodal plane. So these are the orbitals for Butadiene system. So now the Butadiene system is very important, because in examination point of view, either they ask ethylene molecule or Butadiene system or benzene system. So these three are very important. So now we have psi 1 orbital, psi 2, psi 3, psi 4. So when we are talking about thermal condition, so here how many pi electrons are there? 4 pi electrons. So 4 pi electrons we can fill this way. Okay, under thermal condition, HOMO is psi 2. We can say ground state also, we can say ground state is psi 2, and LUMO is psi 3. Now under photochemical condition, what is happening? The one electron from psi 2 goes to psi 3. It exists like this: psi 1 2, psi 2 1, psi 3 1. So here the ground state or HOMO orbital is psi 3, and LUMO is psi 4. Okay, so in this case the con and disrotation is very, very important. So most of the questions will come this way only, like when we have 4n pi system and 4n plus 2 pi system, problems will come based on this only. Okay, for 4n plus 2 pi system we can take a benzene, and for 4n pi system we can take a cyclobutadiene, or we can take this also. Okay, now we'll see how con and this disrotation will be written for the 4n pi system or 4n plus 2 pi system. Okay, because this is very, very important. So now we will go for 4n pi system. Okay, psi 1, psi 2, psi 3, psi 4. So total 4 electrons. First we see the thermal condition. Okay, in the thermal condition, what is the ground state? Psi 2 is the ground state. Like this, we will keep lobes. And what is the psi 2? Psi 2 means there should be one nodal plane and one C2 axis symmetry has to be there, right? So 2 up and 2 down. So this is the molecule like the wave function. This is the arrangement for this psi 2 wave function. Okay, now we do the con rotation here. The con rotation means the both should be in the same direction. Okay, just see here, this one we are rotating this way. That means this shaded one comes towards your left hand direction, this unfilled one comes towards your right hand direction, and these two will be same. So we will write them like this. So here we rotated this one this way, so the shaded one comes towards your left hand direction and this comes your right hand direction. And in this case, this one we are rotating this way. That means this unfilled one comes towards your left hand direction and this comes towards your right hand direction. Okay, and in the 4 and 5 system, these two orbitals are coming same place, so that's why here the con is allowed under thermal condition. Okay, and we'll talk about this also. We can make a table here: 4 and pi, thermal, photochemical, and this is a con, and this is the dis. This here con is allowed. Now we'll see the dis. So dis means we rotate this one opposite direction. So now this will be same, and here we are rotating this orbital in this way. That means the filled one comes towards your right hand direction, so left hand direction here, and here the empty orbital comes. So this is for this. Okay, and as we can see here, the two lobes are different here. That means here this is forbidden. For 4 and 5 system and the thermal condition, con is allowed. This is the for con, because two orbitals are having same lobes, same side. So here this is forbidden because they are having a two different lobes. This is for thermal condition. Now we'll go for the photochemical condition. So what will happen in photochemical condition? One electron will go from here to Psi3. So this is the case for photochemical condition. Now it exists like this: 1 2 3 4. So here the ground state is Psi3. Okay, and then what is the orbital for what is the arrangement for Psi3? There should be a two nodal planes and two plane of symmetry. So one is up, one is down. Here one nodal plane is there, and this is down, no nodal plane, and this is up. So this is for Psi3, and here we can say plane of symmetry. First we'll go for con rotation. Here this one we are rotating this way. That means the filled one comes towards your left hand direction, unfilled one comes here, and this one we are rotating this way. That means the filled one comes towards your right hand direction, and unfilled one comes towards your left hand direction. Okay, sorry, this I made mistake. So we are rotating this one this way. That means see, this one we are rotating this way. We are going from this side to this side. That means filled one comes here, unfilled one comes here. Okay, and this one we are going this way. That means this orbital goes this side. When we are rotating this one, means this comes towards your right hand side. When we are rotating this one, this comes towards your right hand side. So this is right hand side, and this is the right hand side. So this is a filled orbital. Okay, we are rotating this one this way. That means here filled, here unfilled is coming. Okay, now see, in a for con rotation we have a two different things here. Two different means shaded one, unshaded one. Because of that, under photochemical condition, the con is disfavored in case of 4 and 5 system. Okay, and now you do the disrotation, and this one is we are rotating this way, and this will be like this. When we are rotating this way, this comes here. So here the this is allowed. So this is for 4 and 5 system. 4 and 5 system means any anti-aromatic system, if they given in the exam. So you have to follow these conditions. Okay, and some like this they may give like H nu, and here we have to see this is a 4 and 5 system. This is a 4 and this we take cyclobutadiene. This is a 4 and 5 system, H nu. So under 4 and 5 system, H nu, which condition is allowed? Disrotation is allowed. So according to the disrotation, you have to write the product here. Okay, we'll talk about the problems later. First of all, we have to be clear about these things, then we can go for the problems. So the next one is last one. We have 4n plus 2 pi system. We can take a benzene for this example. So how many pi electrons are there in the benzene? 6 pi electrons. That means we'll get a 6 bonding orbitals. Sorry, 6 molecular orbitals we'll get. 4 5 6 1 2 3 4 5 6. So this is psi 1, psi 2, Psi3, Psi4, Psi5 and Psi6. So total we have 6 pi electrons. 6 pi electrons we can fill in this way. So under thermal condition, the ground state is Psi3. Under photochemical condition, the ground state is Psi4. Okay. If you can remember this one, so for 4 and pi it's very easy to write. Without knowing this also you can write very easily. So like we take 4 and 5, 4n plus 2 pi. So under thermal condition, under photochemical condition. So for 4 and 5 system under thermal condition, what is allowed? Con is allowed. For photochemical condition, this is allowed. So if you don't know this one, means if you forgot this concept, just remember for 4 and 5 system, and exactly opposite to this is 4n plus 2 pi system. Just write this here, con here. So this is the conditions for 4 and pi and 4 and pi plus 2. Okay, so we'll see. Now we'll go for Psi3. Psi3 means there should be two nodal planes. So I am not writing these things. I am just directly going into this. So now we have like this. Okay, and here remaining orbitals will be there. Two, one, two. So this is the arrangement. We have one nodal plane, second nodal plane, and we have a plane of symmetry also. We'll see con rotation here. Okay, so we are rotating this one towards this way, and the sorry. So we are rotating this one towards this way, and this unfilled one comes towards your right hand direction, and this will be towards your left hand direction. And similarly here we are rotating this way, that means this comes towards your left hand side, and this comes towards your right hand side. Okay. So this is a con in case of thermal condition. So here the con is disfavored. So what is allowed under thermal condition? This is allowed. So when you're rotating this one in this way, so now and then when you're rotating this way, this empty orbital goes towards your left hand side, and this filled orbital comes towards your right hand side. Okay, now we can see two empty lobes are here. So here the this is allowed. And similarly for when we take H nu condition, for H nu condition means we have to go for Psi4 system. So when you go for Psi4 system, in that case con is allowed and this is forbidden. Okay. Okay, I am not going to explain this Psi4, and okay. This is for Psi4. Psi4 means there should be 3 nodal planes, and then it comes like here we'll take down, then up, down, then up. So this will be the arrangement for Psi4, because here 1 nodal plane, 2 nodal plane, and 3 nodal planes. Okay, so when we do the con rotation here, so we are rotating this way, this comes towards your right hand side, and here this comes towards left hand side. Sorry, So you are going this way and this comes your right hand side. We are going this way and this comes to your left hand side, and this will be here. So here we can see under photochemical condition con is allowed. So if you want to solve any question in a pericyclic reactions, you must be knowing up to this whatever I taught. You must be clear about these things. If you are not clear about these things, you cannot do any questions. Okay, you have to be clear about these things. Next we have 4n plus 2 5 system. Here the methyl groups are opposite direction. One is towards your left hand side, another one is towards your right hand side. We have thermal photochemical condition and thermal condition. So 4 and 5 system, just remember, under thermal condition con is allowed, here this is allowed. For 4n plus 2 pi system, it's just opposite, here this and here the con. Okay, so under photochemical condition it should be a con. The stereochemistry, they are opposite direction, and it should be this bond comes like this, this goes like this. It should be a same stereochemistry. They are opposite. We can take this below the plane, sorry, above the plane, and this should be below the plane. Okay, when we are talking about this, that time the stereochemistry will be the same. This is the products what we'll get. Okay, so till now I spoke about the electrocyclic reactions, and then we have to talk about the cycloaddition reactions. And for cycloaddition reactions, we have to talk about the con and dis. This is for electrocyclic reactions. For cycloaddition reactions, we have to talk like suprafacial and intrafacial. Okay, this I will make another video. So we have spoke about what is con, what is the dis, and which conditions, also thermal condition, photochemical condition. So now we'll go for the electrocyclic reactions. Okay, now we have like this, and the methyl group is this side, and another methyl group is this side. So in a photochemical condition and in thermal conditions, we have to write the product. Okay, so this comes under the 4n pi system. Okay, so now we have 4n pi system. Under thermal condition, con is allowed. Under the photochemical condition, this is allowed, right? So when you are doing a con rotation means, so if the stereochemistry in the starting precursor is cis, that will be a cis. In the product also, that will be cis. If we are doing a this operation, this rotation, if the stereochemistry is cis, then we'll end up with a trans. So this is the thing you need to remember here. And see here cis trans, how you will say, like see, this is the having a z relationship, and here it's having a e relationship. So we can't consider this one like this. We can't say these two methyl groups are trans, because one is z, one is e. So that way we can't take this one. So here what we have to take, see, this methyl is facing towards your left hand side, and this methyl also facing towards your left hand side, means both are in the same direction. Okay, and in the product also, when you are doing H nu, in the case of H nu, you have to get a disrotation. So when you are doing a disrotation, these two are present same direction. After disrotation, these two has to be in opposite direction. And on a thermal condition, we have a con rotation. So con rotation means cis remains cis. okay, and these two are same direction. Now this will be a, it can be either above the plane or below the plane, any one we can choose. So this is the product. I hope it's clear, and if it's not clear further, we are going to solve this kind of problems only, so it will be clear. And we have here same example I'm taking this way. Okay, now we have to write product in a photochemical condition as well as in thermal condition. See, as I said that, so this methyl group is facing towards your left hand side, and this methyl group facing towards your right hand side, and these two are in opposite direction. Okay, and when we are doing HNO in the condition of photochemical condition, so that under photochemical condition this is allowed, right? So this is allowed means cis will become trans, and then trans will become cis, vice versa. So since these are having a trans orientation, the final in the product they both will come cis. Okay, and when we are doing a under thermal condition con is allowed. So under con, trans is remains as a trans and cis is remains as a cis. Okay, so since these are in the trans position, so the product will be this. I hope though it's now it's very clear, because I have explained first example I have taken both are same side. In the second example I have taken in different directions, so now it's clear, right? Now we'll go for yeah. Here we have this example. Here we have pH, here we have pH and CH3. Okay, so now we have to write product for photochemical condition as well as thermal conditions. So here we can see the phenyl is facing towards your left hand side, and this phenyl also facing towards your left hand side, and this methyl is facing towards your right hand side, and this is also facing towards your right hand side. So this comes under same geometry, phenyls are same, methyls are same, so this comes under this example. Okay, so under thermal condition we have con rotation, so this will be remains same. If we take phenyl above the plane, and here also the phenyl should be above the plane and the methyl group should be below the plane. So under photochemical condition this is allowed, that means the stereochemistry will change. So if you take phenyl here above the plane, here phenyl should be below the plane, the above plane will be methyl group, here below the plane will be methyl group. So these three examples, you just remember in examination point of view, if they ask any question, so you have to solve this way. Okay, and this is the electrocyclic reactions, and the ring opening reactions also there. Yeah, ring opening reactions. Here we have methyl group, so here now we are going for from this side to this side. Okay, first we have talk about cyclization. Now we are opening the ring electrocycle, this is called electrocycle ring opening reactions. We are going from product side to reactant side. Okay, so this is having a trans stereochemistry here, both are having trans stereochemistry, and in the product you can write directly, one will be this side, another will be this side, so this will be the product. Because in the thermal condition con is allowed means if you have a trans stereochemistry, then in the product also it should be a trans stereochemistry. And this is about the electrocyclic reactions. Now we are going to solve some of the previous CSR questions which they have asked. Okay, this is about the 4n pi system, and I did not explain about 4n plus 2, right? That also left. So this one and this one are the two examples I have collected. So this comes under electrocyclic ring opening. So how this reaction goes here? OH, and this bond goes this way, and this bond comes here. Now it will become OH like this. And the second step is the cycloaddition reactions that we'll talk tomorrow. This we can say the Diels-Alder reaction. So since here no group is there and we no need to worry about this, imagine that here OH is there, okay, and the condition what he has given is it's a thermal condition and the photochemical condition. Imagine this is the thermal condition and this is the photochemical condition. So thermal condition means this is the here only 4 electrons are involved, that means the 4n pi system, okay. 2 pi bond, 1 sigma bond is involving, only 4 electrons are involving, that's why 4n pi system. So 4n pi system thermal condition means it's a con. So these two are in opposite direction, one is above the facing upward, another is facing downward. It should be like this, okay. Now here in the Diels-Alder reaction, this we'll talk tomorrow why these two, because this is above the plane, this is below the plane, why these two are coming same side I will tell tomorrow while explaining Diels-Alder reaction. And here for up to this for under photochemical condition the this is allowed, so that's why this will be, one will be above the plane, another one will be like this, okay. So now this further undergoes Diels-Alder reaction, okay, and this reaction goes fast and this will be going slow because the steady crowding of these groups. So this we'll talk tomorrow. And here we have this is also the what we say, we can say like this, okay. And here we have this kind of arrangement, and here OM, okay. Here also for the Diels-Alder reaction, okay. So this is about the basics of today I will talk about the basics which we need to remember for pericyclic reactions and electrocyclic reactions we spoke today. And tomorrow we'll discuss about the cycloaddition reactions and sigmatropic reactions. So till now if you have any doubts you can write in a comment box, and if you like my video please subscribe to my channel and please forward to your friends, and you can comment also. Thank you.